project. Let me do the codes for the support vector machine. We are going to take one project and we'll do it in Python language. We will see all those steps in the Python language for the support vector machine. For example, the project name is breast cancer data. We're going to do a Python project which tags breast cancer data using support vector machine. So the very first step is load all the libraries from the Python. This is the very first step. In the first step, you have to load all the libraries, all the respective Python libraries. For example, from scikit-learn, import datasets. It is a built-in datasets. We are doing the built-in datasets. There is no CSV file. It is a built-in dataset in the scikit-learn. sklearn means scikit-learn. It is a Python library. And then from scikit-learn.model selection, import train test split, which is used for the train test splitting. Then from sklearn, import SVM, which is support vector machine. Then from sklearn, import matrix. Look, this will be the very first step in the Python language. You have to load all the respective libraries from the scikit-learn. Look, sklearn means scikit-learn. It is a Python library. It is a Python library which is used for the machine learning. So from scikit-learn, this is the library, import datasets. We are importing dataset from the scikit-learn. It is a built-in scikit-learn. And then from scikit-learn.model, this is the scikit-learn library. This is the submodel. Dot model selection is the submodel, import train test split, which will be used for splitting the data into train and test. And then again from sklearn, which is scikit-learn, import SVM. What is SVM? SVM is support vector machine. Import support vector machine from the scikit-learn. Then from scikit-learn, import matrix. Look, matrix we need for the accuracy, for the precision of the model, for the confusion matrix, and also for the classification reports. Everything comes under the matrix. I repeat it. Matrix is the module that we imported from the scikit-learn. sklearn is the scikit-learn. Scikit-learn is a Python library. It is a Python library which is used for the machine learning. So we are going to import matrix. Matrix covers the confusion matrix, accuracy, precision, classification report. All the final evaluation steps come under the matrix. As I told you, we are importing built-in datasets. It is a built-in datasets from scikit-learn. And then the second step will be to load the data. Load the data from the scikit-learn, where we have d equals to datasets dot load breast cancer. Look, we are loading the data. We are loading the data. Which data? Breast cancer. In the datasets, which is the built-in datasets in scikit-learn, we have different type of data. But we are loading breast cancer. We are loading breast cancer data out of the datasets. I repeat it. It is not my data. It has been built by someone else, which is a built-in datasets inside the scikit-learn library. We are just importing that dataset, which has different data types. We are concerned with the breast cancer. We are loading breast cancer data. So I just gave the name D to this whole thing. The name of this data is D now. It is just a variable name. It is the identifier. It is a placeholder which keeps the information in the computer memory. Placeholder identifier is the identification for this whole thing in the computer memory. So this whole thing has been named with the D. I gave the name D. You can give any name. You can give cancer, you can give D, you can give C, whatever you want. It is just a simple name. It is just a variable name. It can be anything. I simply give the D. D stands for the data. So I just give the name D to this whole thing. When you run this function, the breast cancer data will be loaded. This is my second step. And then to explore the data, we are going to play with the data. So far we have loaded the breast cancer data. Now we are going to play with the data. What is inside the data? How the data looks like. If I take the print of D, what is D? D is this whole thing. This whole data has been named with the D. So D stands for this whole thing. So rather than to put everything here, you simply put the variable name, which is d. So I'm going to take the print of d. When you take the print of d, you will get this output here. Look, this is the respective data. This is the respective breast cancer data. When you take the print of data, this is the description of the data. Look, we have DESCR, which is description, and then we have the data in the array form. It is the data in the array form. These are the features. These are the features named in the array. These are the targets. The output is in the binary form. It is in the 0 and 1s form. The output of the support vector machine is in a binary form here. Target means the output. The output of the data will be in this form. These are the features. These are the data points. What are features? Features are the data points. They are the components. These are the components here. So this whole data has been represented in the array form along with the output, which is the target. The output is in binary form. That's how the data looks like from inside when you explore it by using the print function. This is the inner side of the breast cancer data, which we have loaded from the data sets from the scikit-learn of the Python library. We are just exploring the data here. Now to explore the output, now let me check the output. What is the output? The target. Target is the output. Simply take the print of d of target. Look at here, the output is the target. The name of the output is a target, T-A-R-G-E-T. This is the target. This is my target. It is the output. It is the output of the breast cancer data. So to explore only the output, you simply take the print of target with a D. Take the print of D of target. You cannot simply put target here. You have to put D here. What is D? D is the variable name which shows the data, the breast cancer data. It has been named with a D. It can be any name, can be D, can be C. It is up to you. But whatever name you put it here for the variable, you have to use the same name all the way. So here you have to put the D. You cannot change the D. You cannot change the D with the X or Y because we have already used the D. We have already used the D, which is the name of the data. So D and then of target inside the quotes along with the close brackets. Don't forget, don't put parentheses. If you put parentheses, you will get error. We're only taking the print of target out of the breast cancer data. So you have to put D of closed brackets and then inside target within the quotes. Don't forget the quotes. If you miss the quotes, you will get syntax error. So don't forget it. It is a simple Python program. Now when you run it, you will get this output. Look at here. We only get the output, which is the target. Target is the output. We only get the output here. So the whole output is in a binary form. It is in binary form, in 0s and 1 form. Look, we have total 569 components in the output. 569 components in 0s and 1s form in the output, which is the target. Target is my output. 569 values of 0s and 1. Now to go for the step 3. In step 3, we want to clean the data. In this case, the data is already clean. There is no need to do the cleaning process. Why we need the cleaning process? We have already discussed this thing, that sometimes the data are missing some terms. There are some missing features, and also there are some duplicates. So they need a cleaning process. How we can do the cleaning process? We do the regular expression for the cleaning process. But right now, since this data is a built-in data, it has been already cleaned. There is no need to go through the cleaning process. Therefore, don't interrupt the step 3. Just simply ignore step 3, which is the cleaning process. Straight away go for the step 4, which is split the data into train and test. In step number 4, we are going to split the data into train and test. Look at here. For the training purpose of the model, of the SVM model, of the support vector machine model, we need train data and also we need test data. For the train data, we give training to the support vector machine. With the test data, we are testing the machine later. Once the machine trained, then we test it with the help of the test data. So we take some percents out of the whole data for the test and we keep it on one side. So once the machine trained with the training data, then we pick this data like 20% or 30%, and then we will try to test that model with the help of the test data. So this will be the Python expression for the splitting of data into train and test. Look at here, we have xtrain, xtest, ytrain, and ytest equals to train, test, split. If you remember, we have already imported this train, test, split from the scikit-learn, from the submodel of the model selection. We've imported this train, test, split, which is using for splitting the data into train and test. So it equals to train, test, split, and then d dot data. You know that the name of the data was d, if you remember. Don't forget the name. You cannot replace d by something else now. Once you give the name d, you have to use d all the way. If you give the name cancer, you have to use cancer all the way. If you give the name k or p, you have to use that variable, that name all the way. So since we have given d there, then you have to use d all the way. So train, test, split of d dot data. What is data? Data is my whole breast cancer data. And then comma d target. D target means it shows the output out of the data. It shows the full data out of the data. D dot target shows the target, the output, only the output out of the data. And then comma test size. The test size has been given 0.4, which means 40%. 40% of the total data has been allocated for the test, for the testing of the model later. So the test size is 0.4, which means 40%. And the random states are 209. What are random states? These are the random samples of the data. I randomly pick 209 samples of the data. So the random stats are 209. Now the data has been split into train and test. Xtrain, Xtest, Ytrain, Ytest. So Xtrain and Ytrain are used for training the model. Xtest and Ytest are used to test the model later once the model became trained. So the test size, the test data is 40%. If you have 209 data samples, out of 209, 40% will be for the test and 60% will be for the training purpose. Look, we keep the test data on one side in safe zone. Once the model became trained with the help of the 60% data, which is the training data, then later we pick that 40% test data. That what is the prediction of the model? What is the output of the model? We do testing of the model with the help of the test data once the model is trained. So I hope you got the point now. 209 are the random state. You can pick 200, you can pick 300. These are the random states of the data. So since we have split the data into train and test, now the next step is the fifth step where we are going to create the machine model. In this phase, in this step, we will create the machine model, the support vector machine model. So it can be created as model equals to SVM support vector machine model dot SVC support vector classifier of kernel equals to linear. So there we have created the support vector machine in a one line. This is the one line code where we have created the support vector machine. I just give the name model. So now the model of the support vector machine has been created. I simply give the name model. You can give any name. You can give classifier, you can give model, you can give A, you can give B, you can give C, whatever you want you can put. So I give the name model to this support vector machine model. It has been named with the name model. Now SVM, in SVM support vector machine, we have a subterm here which is support vector classifier. Look, in support vector machine we have two subterms. One is SVC. SVC stands for the support vector classifier. Which is doing classification, and the other is support vector regressor, which is SVR. SVR is support vector regressor, which is used for the regression of the support vector machine. So don't forget, I repeat it, in SVM we have two subterms, SVC and SVR. SVC is the support vector classifier and SVR is the support vector regressor. So since we are doing classification here, so we're going to use SVC, support vector classifier. SVM is a support vector machine. But what is the kernel? The kernel is linear kernel. We know that we have three types of kernel: linear kernel, polynomial kernel, radial basis kernel. Here we are using linear kernel. because here the data is in a non-linear form. Look, why we are using the kernel? Because in this case the data is in a non-linear form. It is not a linear. We cannot use the linear support vector machine here. I repeat it, we are not using the linear support vector machine because the data is in a non-linear form here. So we are using non-linear support vector machine here. We are doing classification here. We classified the data in their different classes. Therefore, we are using SVC support vector classifier along with the kernel. In non-linear support vector machine, we use kernel trick to go from low dimension into higher dimension so that we can separate the data nicely. What kind of kernel we are using here? Linear kernel. So there we have created the machine model, which is the non-linear support vector machine. Non-linear support vector machine model. Step number 6. What is the step number 6? In step number 6, we are going to train the machine model using fit method. So far we have split the data into train and test, and then we have created the model, which is non-linear support vector machine model. Now we are going to train the machine model. We are going to train that machine model, which is non-linear support vector machine model, by using the fit method. We will use the fit method. So we can write model.fit of x train, y train. What is the name of this non-linear support vector machine? Its name is model. I gave the name model here. So you have to put model.fit, fit method, and then of x train, y train. For the training, you have to use only the training data. As I told you, we have x train, x test, y train, and y test. For the training, we are going to pick only the x train and the y train. The test data, which is x test, y test, we will put it on one side in a safe zone, and we will not use the test data for the training purpose. Its size is 40%. Once we train the model with the help of the x train and y train, which is the training data. Look, what is x train and y train? X train and y train are the data along the x-axis and y-axis. This is the data, this is the training data which we are using for the support vector machine model along the x-axis and y-axis. Therefore, we give the name x train and y train. Now, it is in a non-linear form in 2D. Since we have both x and y axis, therefore, this non-linear data is in a 2-dimension. We have a 2-dimension non-linear data. Now we are going to change it from the 2-dimension to the 3-dimension to separate the data. So here model.fit of x train, y train is used for the training purpose. So in one line of code, we have trained the model. Now we have trained the model. The model has been trained using the fit function just in one line code in Python program. It actually looks like in this form, where the support vector classifier has c equals to 1, the value of the classifier is 1, and then class weight, coefficient, decision function, these are all the parameters. These are the parameters of the support vector classifier. So now the model has been trained. What will be the next step? What will be the 7th step? In step number 7, we are going to do the prediction of the model. We have created the model. We have trained the model. Now in this phase, we are going to do the prediction of the model. So remember, I have told you that we have a test size data. I keep the test data, which is x test and y test, on one side in a safe zone, which has not been used for the training purpose. Now in step 7, I'm going to pick that test data here and will apply to do some kind of prediction. That what is the prediction of the model? How the model predicts? We can do this thing with the help of that 40% test data. So we can write prediction equals to model.predict of x test. Look, we have x test data and y test data. I'm picking only x data here. So prediction equals to model.predict of x test. Remember, for both the x test and y test, we have 40%. We have 40% data. So I'm picking here only the x test. Look, this prediction is just a variable name. It can be any name. It can be prediction. It can be pred. It can be p. Whatever name you want to plug in, you can do it. It's just the variable name. It is just the identification for this whole term. So prediction equals to model. What was the machine model name? The machine model name has been named with a model. Its name was model. So you have to use that model all the way. So model.predict. Look at here, the name of this SVM model is model, M-O-D-E-L. So you have to use model all the way here. And similarly here, model.predict of X test. Now if I take the print of prediction, just simply take the print of prediction, you will get this output here. Look at here, we have total 228. We have total 228 numbers in zeros and ones form. So this is the output for the test data. Remember, we have used 40%. If you remember last time in the target, which is the output, we have total 569 numbers, 569 elements in the zeros and ones form. It is in array form. But what will be the 40%? Its 40% will be around 228 something. That's why we have 228. This is the output, this is the target. For what? For the test size. It is 40%. It is 40% out of the total data. As you saw, that for the total data, in the output we had around 569 ones and zeros. Now since we are using test data 40%, so its 40% will be around 228. Therefore, when you do the prediction, when you take the print of prediction, you will get 228 ones and 0 in the output in the array form, which is the test data, Look, we are simply doing prediction here. So we have predicted the test size successfully here. Now what will be the last step? The last step, which is the step number 8, will be the evaluation of the model. Final evaluation of the model. What is the output of the model? What is the evaluation of the model? In evaluation of the model, we're going to check the accuracy of the model, precision of the model, and classification report of the model, confusion matrix of the model. Look, these are the parameters determine the stability of the model, the accuracy of the model, the precision of the model. So the accuracy equals to matrix.accuracy score of y test, comma y prediction equals to y prediction. Look, if you remember in the very first step where we have imported the libraries from the Python, we have already imported the model matrix model from the scikit-learn library of the Python. It is actually used for the accuracy, for the confusion matrix, for the classification report, for the precision of the model. So it covers everything. Now accuracy equals to matrix.accuracy score of y test, comma y prediction equals to prediction. If you remember, X test and Y test has been placed in a safe zone. These are just for the testing purpose of the model. We haven't used these data for the training. For the training, we have used X train and Y train. The test data where we have X test and Y test will be used for the testing of the model. Now look at here. Prediction equals to model.predict of X test. We have taken the X test with a prediction name. So we're gonna take the same prediction here, which is Y prediction equals to prediction. It is actually the X test value. Y prediction means that we are taking the prediction of the Y. It is just a simple name. Remember, it is just a simple name, Y prediction. We have Y test and Y prediction. When you make Y prediction equals to prediction, it means that this is my X test. Prediction equals to model.predict of X test. We have taken the X test with a prediction name, So we're gonna take the same prediction here. So we're gonna put Y test, comma X test. I repeat it. This is just a variable. Name. You can put any name. It's like Y test and Y prediction. Y prediction is actually prediction. Prediction is actually the X test. When you take the print of accuracy, you will get this kind of output. The accuracy is 92+%. This is the one line code for the accuracy. When you take the print of accuracy, remember, print of accuracy, this is the variable name. Whether you put accuracy name or A or B or whatever you can put, it is just the name. Take the print of that name. When you take the print, you will get this output. So we have 0.925, which means that the accuracy is more than 92%. So it means that the model is in a stable position. It is in a good condition. If you have 92% accuracy rate, it means that the model prediction and the model evaluation is in a very good condition. The model is doing well if you have more than 90% accuracy rate. It is more than 92% accuracy rate. Look, you can also write print of accuracy, comma accuracy. You can simply put accuracy inside the quotes and then comma accuracy. In the output you will get accuracy colon 0.925 and so on. It is up to you. So whether you put this line for the print function or simply take the printf accuracy, you will get the same output. Now to take the printf classification report. Look, in classification report we have everything. We have the accuracy rate, we have the recall rate, we have the precision rate. So this is the one-line code. This is the one-line code for the classification report. Look, I'm just giving the name C report, which means classification report. Matrix is the submodel that we have imported from the scikit-learn library in the Python language. It covers accuracy rate, it covers precision rate, it covers classification rate, it covers confusion matrix rate. So whenever you want to play this kind of stuff at the end, you must have matrix sub-library, which has been imported from the scikit-learn library. So we have classification report equals to matrix.classification report of y test, comma, y prediction equals to prediction. Again, we have y test and we have y prediction equals to prediction. If you remember, prediction is actually x test. This prediction is a variable name which we have done for the x test, if you remember. So this y prediction is actually my x test. Therefore, we're gonna have y test, comma, x test. Look, this test data is very important. It is very important. We're gonna check the model at the end, that what is the accuracy rate, what is the precision, what is the stability, what is the confusion matrix, what is the classification report, and what is the prediction of the model. That's why we keep some test data out of the total data. It can be 40%, it can be 30%, it can be 20%, but make sure test data has not been used for the training purpose. It has been kept on one side in a safe zone. You shouldn't interrupt the test data during the training. Once you train the model, then you can pick that test data to check the accuracy, to check the prediction, to check the stability of the model. It is just for the testing purpose. I hope you got the point. So let me take the printf C report. It returns this output. Look, this is a complete classification report. It is a complete classification report here. If you take the printf classification report, C report means classification report, we have 93%, almost 93% precision rate, and recall is 93%, and similarly F1 score is 93%. So in classification report we have precision, we have recall, we have F1 score, we have other parameter. Now look, the accuracy and the precision is more than 92%. More than 92%. It is 93% actually. We got this output just in this one line coding. This is the actual coding actually. This is the step where we load the data. And this is the splitting of X-train and Y-train data. This is the creation of the model. Look at here in step 1, we imported all the relevant libraries in the Python. In step 2, we have loaded the data. In this one line code, we're gonna load the breast cancer data. And this is the splitting of the train and test data. With this line of code, we're gonna split the data into train and test. Look, the name of the data is D, therefore you have to put d.data. D.data means the whole data, comma, d.target means only the output of the data, comma, test size equals to 0.4. Remember, the test size was 0.4. The random sample of the data were 209. So here in one line we have splitted the data into X-train, X-test, Y-train, and Y-test. Now as I told you, the X-train and Y-train data is used for the training. For the training purpose, we are going to train the model with the help of the X-train and Y-train. X-test and Y-test will not be interrupted. This X-test and Y-test, which is 0.4 means 40%, will be kept at one side in a safe zone. We will not interrupt the test data. Once the model is trained, then later for the prediction, for the testing purpose, we're gonna pick that test data and we'll check the accuracy, the stability of the model, the prediction of the model. In fourth step, we have created the model. We have created the nonlinear support vector machine model, which is model equals to svm.svc, which is support vector classifier with the help of the linear kernel trick. So with this one line code in Python, we have created the whole model. And then in the other step, we have trained the model. We're going to train the model. Once you create the model, you have to train it. For the training purpose, we are using fit method. model.fit of X train and Y train. As I told you, for the training purpose you have to use the training data, not the testing data. Therefore I pick only X train and Y train data, not X test and Y test. Look, the name of the model is model. This is just the name. This is just the variable name. You can put any name. You can give the name cancer, you can give the name A, you can give name B, you can give name C, whatever you want. It is just a variable name. It is just the identifier which identifies this whole model, this whole thing. If you put model here, you have to put model here, model.fit. And then in the other step, we're gonna do some prediction. So we have trained the model now. In the next phase, we're gonna utilize the test data that we kept at one side. So for the prediction of the model, first I took X test data to predict the model, that what is the prediction of the model after training, what is the output of the model, what is the stability of the model. And then in the last phase, in the last stage, we will check the evaluation of the model. In the evaluation of the model, accuracy, we have precision of the model, we have confusion matrix, we have classification report. These are the final parameters which will determine the stability, the nature of the support vector machine. So this is the last and the final step. The actual coding for this whole project, of the breast cancer data, is only in 11 lines of code in Python. In these 11 lines of codes, this is the complete coding. For this whole project.